And good morning. How is everyone today? All right, so today we will be working on. Let's get the little graph up. Where is it? Monodraw. Boom. This is our application. So we will be working on a portion of the new application stack. The application stack consists of an application that a developer would work on. They would create their little application that they want to become the next greatest thing. They would upload it into our new service, the new stack. And the stack would allow their new service to scale out horizontally fairly well. It would be using simple technologies, SQLite, proxy that we've written, a VFS plugin to be able to replicate SQLite from one place to another, live always on data archive for their databases so that you can go back in time and download your database at any point, and so on. Today, we will be working on data archive and building out an interface so that we can abstract away our storage cluster and build out unit tests. So we have a trait. Let's pull the trait up, called storage. We have implemented this for SLED, which we will be using for our testing. And we are in the process of implementing this for TiKV, which we will use for production. And I am so distracted at the moment, listening to Fuji's Killing Me Softly. Man, I listened to this song so many times growing up. I just want to sing it, but I'm not going to. For both of our benefits. All right. So the TiKV portion, we've implemented compare and swap. I thought we did a little bit more than this. Did we not? Hit that real quick. Oh, we have Z release notes. Let's look. So much changes constantly. I am impressed. There's now an uninstall script. Okay. Wow. And more Vim bits. They keep adding these. Their Vim mode is just getting better and better. Oh, look at that. Method and comments. Oh, interesting. So does, oh, look at that. Sections can go by method. Oh, look at that. Beautiful. Okay. Nice. Well, let's implement range. Oh, wait. Nope. Let's try again. For TiKV, let's implement range. I'm going to bump up the font size. Let's see, we want over there. Range. Now, for range, we take what we will describe as a range and a limit. So in this case, there are only so many units that we want to be able to return from range. So let's see what we have. We have self.client, which is our TiKV client. I believe, this isn't too far off. But you know what? For the stream, I am actually going to disable Copilot. I'll just disable it. I know it's authorized. I want to leave it authorized. If you'd rather not have Copilot at all, you can disable it. Okay, in your settings. Lovely. I would rather have a key command. Oh, interesting. Hmm, try that. Settings. So language models, assistant, yada yada. Do we have features already? We do not. All right. So let's implement range. Now, let's review what we have. On our object, we have a raw client. Let's look up the documentation for raw client. Where are you? All right, so for range, we'll be using scan as we want to return a key value pair. Seems fairly straightforward. We do have a limit, so we do not have to implement that ourselves. We just have to change the return type. I think that's going to be the bulk of our work. self.client.range scan. Self.client.scan. We give it the range. Limit. Await the result. Now this should give us an error. What kind of error does it give us? Arguments to this method are incorrect. Arguments to this method are incorrect. Hey, morning, Nightshade dude. How you doing? That means that expected U32 found U size. Why are they not using U size? Okay. Range or bound range from R is not satisfied. Requirement for R to implement. Okay. Interesting. We do not want that in our trait. So we have to implement that ourselves. Now, this takes a bound range. Actually, let's do it that way. From range dot, is it start bound? End bound. Now these are the wrong kind. Right now we have, oh, you know what? We should extract these out first and convert them. Now, what are the actual types here? We have this as the standard ops range bound of something asref Hue8. Now, do we need to convert? Okay. No, we just doubled it up. We need this to be bound key. Can we not convert into that directly? But it's an asref slice of U8s. Trait bound from that is not satisfied. Required. Fancy. Let's go look at bound in TiKV. Oh, trying to get there. Range bound. That's a standard bound, but key is the important piece. Key from, okay. What does that give us? Oh, interesting. These have to be owned. How do we get the element out of a bound? Oh, we can map it. Okay. I did not know you could use that. So letting from equals range. So start bound dot map, and we will map the start, whatever that value is. I'm using v there for value. Now v in this case is a k. We want this to be into a vector, back from v. Can we do this? Oh, it's not satisfied because we didn't put this in our trait. As ref. All right, getting closer to vec. Bound vector of U8s. And it needs to be a key. No, that's not it. Qualify as TiKV key. All right, now same thing for 2. Let 2 equals range dot end bound. We will map that. Good. So we have from to range. Something's bugging me here. Let's Oh, I can't do that there. All right. It's worth a try. On to the error message. And the return type. Oh, goodness, our return type is much different. So we need to map that and change our error types. Let's change our error types first. What do we have here? Range entry. It's not really a range entry error. That would be for an element. How did we do this with sled? Yes, we do. We do just bubble up the range entry error. I think I want to rename that. Okay. Just range error. Now for our return type. Now what is V here? V is a KV pair. Call it an entry. Entry is a little bit more specialized. Let's just call it a pair. And we need to generate a tuple of vector U8s for our key and value pairs. Pair dot, do we have a 0 on it? Let's look at what is on a pair. Wrong one. KV pair. Yep. Tuple fields 0 and 1. Lovely. Key and value. Key. Ordered sequence of bytes. Okay. How do we get access to, well, that ordered sequence of bytes is fine. No traits. How do we get the bytes? I want the bytes. 2 encoded. Key, no. As a ref, clone. Did I not get the bytes? That doesn't seem right. E from that. It's storing it as a vector of U8s, but it's not accessible to us. is empty, 0 terminated, push 0. These are all pub supers. Here. Basically, we just take a reference to it. That gives us the value. E4. See, here we go. Oh, wow. Okay. Why isn't that? Oh, it's here? No. As ref. Interesting. Like where is that information here? I guess we would have to look for it down here. Is that this one? No. Ah, from key. They didn't read very well. Okay, well, interesting. So we want pair.0.into pair.1.into zero. There's no field 0 on that. Oh, you're kidding. AV pair. I do see it here. Is this not a KV pair? Oh, it's a vector KV pairs. Oh, goodness. Okay. So then, on the vector of KV pairs, we must iterate over them. Pair dot into iter. We will map those. And what do we call these pairs? These are pairs. Map pair. Pair.0 dot into. This will be in a tuple. Wait. Value of type, vector, yada yada, cannot be built from elements of this type. Ah, because key is different. Okay. So we have to into the key. The value is simply a vector. And that is range. You know, today it looks like the Twitch bitrate is much more behaved. I don't know why I was getting crazy spikes yesterday. And welcome to all y'all over on YouTube. How are you? We have to box this. So we could do that way. Boom, done, good. And thank you for the follow. Okay, there's this. Can we simplify this? I would like to simplify this piece here, just to reuse it. It's the same code over and over again. We're being explicit about which key this is. Other places in this file, we actually use super key. As we have our own KV pair and key and value defined. Let's do range keys. This one will be very, very similar. Let's look. So TiKV has a scan keys. It will be very, very similar. We get a range bound, we have a limit, and a result. I'm just going to take the previous function and trim it up. It is very nearly there. So we're just going to take this one, range keys, get rid of to do. We have our range bound. We will, what was it, scan keys. Passing that, our error type is wrong. Our error type is fine. Our return type is wrong. As we no longer receive key pairs, we receive a vector of keys. Keys into iter. Now for our key, we need to change its type. And that's it for range keys. We should simplify this. We need a way to convert from their type to our type. Let's have a little function here. Oh, we have to implement this elsewhere. Let's impl. Oh, we already have an impl. This is not public. So we need a function. Function convert range. And what is the type that we need here? Let's bounce back. Standard ops range. Well, basically this. We have our range. Going back down here, we want basically this. We need a return type. It's never used yet. That's okay. We will use it now. Does it really need to be a function on this struct? I don't think so. It's just a little utility function. We can tuck in here somewhere. How about at the bottom of this file? There we go. Range keys. There we go. It's no longer on self. It's a free function. There we go. Much better. We could clean this up, dry it up a little bit, but I don't think it's worth it. Now we have batch put and get. Let's see what batch put looks like. Pairs into iterator, something that can be converted into a KV pair. All right. So our KV pairs are just vectors of U8s. Right, it's a tuple, vectors, very simple. Let's see if this would work. Self.client batch put. Does pairs just work here? Let's have pairs. Let pairs equals pairs into. So now we have an iterator. Map. KV pair. Let's just call it pair. Can we into that? Oh, this needs to be into iterator. Okay. So await that. Expected result, found future. All right, now it's just the error types. Dot map error. I like that little macro there. Okay, that worked out pretty well. Now for a get. We would need to be able to get values from our KV store. Pass in something that can be turned into a key. This is a TiKV client key. Okay, none indicates the key does not exist. That client I get. Let's see, give it key. This is going to be the wrong type. Now we have a slice of U8s. This isn't quite there. It needs to be owned. All right. We need to await and map the error. Super error. It's a super error. Get error. Source is error box. And that's it. It's not used yet, but it looks mostly okay. And these are never used because this code isn't used. Okay. What font is this? It looks quite nice. The font here, it's whatever Z comes with by default. Let's see. Z mono and Z sounds. For code from code. Okay. Looks like it's a variant of this. Even with the pronunciation here, I'm not sure how to say it. It's like a Yosefka. Yosefka. Anyhow, I think that's what it is. Yep, you're welcome. All right. So from there, let's go back to MonoDraw. We now have our little test interface built out. So we can start to build our server. We can instrument it with, goodness. Well, we'll just start up a test harness, use duplex for client and server integration. We'll need to create a custom server so that we can tell it to use the sled backend as opposed to the TiKV backend. Then, given the two different backends, we'll be able to separate our production and test environment. We could then inspect the results of an operation in our test harness to ensure that it's doing exactly the right thing. And that would be nice. this is our main function. Now, we need to extract some of these pieces. Why do we have a module for data archive inside of data archive? That's weird. My music stopped. Network still seems to be okay. Okay. So let's go to where this is created. We have some telemetry, just random stuff getting set up. Here's our listening setup. We'll need to be able to set up different kinds of listeners, similar to what we did with a data plane. We will also need to be able to specify different backends. Oh, and thank you for the follow. Let's look at data plane, DB. So our testing is mostly at the bottom of this gigantic file. To take a look, where's page down doesn't work. Oh, it's in the, where is it? Sync manager? No, almost. You can see that here we have a connection provider. We'll need to do the same sort of thing. Going down to the tests. Mod test. Starting 1,000 lines in. It's so buried in here. We initialize our logging, create a new test context, or test context ends up creating some temp directories, which we will also need to do. Test archive. Test archive. Okay. It's a tempter and whatnot. Here, we create our server that we're testing. Well, this is actually our test server, so our fake server. We'll do the opposite. We'll have test clients. We'll need to use duplex in order to connect the two. It might actually be a little easier this time because we will not have to write a fake server. We're writing a fake database in the backend, which we've mostly finished. So we'll be able to create one of these and pass it in. We were here. We do not have many files in this project yet. We've got our little storage piece. Lib, not much there. I think we should get our server extracted from here and then associate our unit tests with that module. What is this? Sample data, reverb data stream. What is that? What was this build? Data stream. Oh, this is for sending data to the server. Okay. Yeah, we'll be implementing that. Oh, interesting. Do we end up using just the two interfaces for sending data to the server and then this one for getting data out of the server to test it? Maybe. I feel like I want to test each one of these independent of each other. Do I name them that way? Because proto files are named that way. Trying to come up with better names for these modules, data archive and data stream. The data stream portion, it receives mutations from data plane as they are sent to data archive. That's this side of the house. Data archive is for getting data out of the archive and into data plane. So you can see data plane does both because at any given moment, this machine here could be, elected to be the writer. Let's say this machine crashed for some reason. Who cares? This machine would then suddenly become the writer and need to receive mutation requests. Maybe we call it mutation. Sometimes just talking about these things helps you come up with a name. They're both mutating something. I don't like that. Well, it's good that they are mutating something, but the name doesn't fit. Maybe write and read. Hey, Luke, welcome. So the software we are working on is part of this project that I call Reverb. And it's basically a stack that manages applications. So imagine that you're a developer working on some sort of website. Instead of having, let's say, SQLite for your local development and then tossing it onto some larger hardware for production, the goal is to be able to keep the same sort of simple stack from your local machine out into production. So just your project plus SQLite, you toss that into our stack, and we would deal with scaling out your application horizontally. So most web applications are very read heavy. So what we would do is take the data mutations that happen. Our proxy would send mutations to a single machine. The mutations would happen. We would watch them using our custom SQLite plugin. It's called a VFS, basically a virtual file system. That virtual file system would go into data plane, send the mutation information to our database backup system we call data archive. Data archive would then stream the data to any of the readers, and this would happen very, very quickly. And so that's basically it. Your application gets scaled out horizontally. You don't have to worry about changing databases or whatnot in order to, go into production. SQLite does quite a bit, and I think it's with the right sort of architecture, it can be used to basically host nearly any website. I think, no, I'm hoping to be surprised. I'm optimistic, very optimistic about this. I like having the live updates, the live archive. So the piece we are actively looking at is data archive. We just implemented an interface for storage. Oh, cool. You achieved a baby version of the replication I'm talking about recently with MySQL's bin log. Yes, yes. Yes, you'll want to make all of that just part of the platform. Just toss up your application and it scales. I want it for my projects. So SQLite is very cool, and you can make it scale. All right. So distributed SQLite? Yes, in a way. It's intended to, for at least the first release, have a single machine be the mutation server. Right? It receives all of the write requests, the mutation requests. And then all of the other machines can basically scale out the reads. Yeah, SQLite is pretty cool. I'm looking at both the conversations going on between Twitch and YouTube. So after the first version, I believe that we could get even better kind of write capabilities by assigning certain portions of an application to a certain mutation server. Right? So we could have multiple mutation servers by splitting up the SQLite databases. Right? First, you want to shard out any database. Right? So design your sharding from the get-go. If you're designing a forum, maybe don't have one database represent the forum. Have a database per thread of your forum, right? Just go crazy with just sharding it out. And that would give you the ability to scale these things just really, really well. Because the choke point here is going to be the writes, not the reads. And so if we can solve for that, just with sharding, right? Put that at the beginning of the equation, beginning of the design, everything falls into place. I think that would be the only real requirement for tossing an application into this stack. So I would say, figure out your sharding. Right? Feel free to create as many databases as you want. It'll handle it. Right? Many, many small, mutable databases is better than one gigantic one. So, and SQLite's great. You can query across database files, all sorts of things. It's really neat. But we're coming up at the end of my time here, so I need to figure out who to raid and gotta get on to work. Let's see, same category, search filters. We're gonna raid for Rust. I do appreciate y'all hanging out. I'm gonna try to basically take the streams that I'm doing and trim them up and make them kind of short, more consumable content, and I'll toss those on YouTube. So yeah, I'm gonna try to get these streams to become little videos on YouTube. Cut out some of the banter, you know, all the witty goodness. Let's see. Ooh, open source foundation DB bindings in Rust. That looks interesting. But it's in Francais. I don't think we'll do that. All right. We will raid Future Highway. Let's start that raid. All right, y'all. Take care. Till next time. Bye bye.